All right, here's the solution to our assigned problem. Maybe I'll bring this a little closer. I do my steps over here to figure out how to break up the middle term. So I arrive at the point where I see that I should take x and think of it as 4x minus 3x. Then I group, and then I factor everything I can from each group, and I see the x plus 2 underlined in green there appears on each side because we've done our work correctly. Factor that out. We arrive there, set each factor equal to 0, solve, and negative 2 looks like the easier one to check, so I plug negative 2 back into the original equation up here, get my 0, things check out. So that's good. Now the second method is a method that didn't exist back in my day as a student, but now that you have all these graphing calculators, you can actually use a graphical method. So look at example 4. This is on page 184. They call it graphing and factoring methods combined because there is going to be a little bit of factoring in there, as you'll see. You can't get the calculator to do the whole thing for you. Suppose you have a problem like that. If you tried to factor this, it would factor pretty well. But suppose you just want to try using your graphing calculator. Well, use the calculator to plot this function. You're going to get an image like this on your calculator. Okay, you can look at your calculator and see that the y-intercept is negative 10. Of course, you can look right there and see that same fact. Now, it looks like the graph is going straight through 2 on the x-axis. But your calculator may not allow you to be sure of that. So what you would have to do is go over and check. Let's take the original equation and in place of x, I'll put 2. And we'll see what we get. That should be an equal sign there. Okay. So I'll put the question mark over the equal sign. We get 3 times 4 minus 12. 12 minus 12, 0. Okay. So that works out. But the problem is the graph doesn't seem to hit exactly on minus 2 or minus 1 or any other number there. We seem to have some kind of fraction or something in between. Who knows what kind of number it is. Well, what you're going to have to do then is algebra. Good old algebra. Here's our quadratic, right? We have figured out that 2 is a solution. 2 is a root of this quadratic equation. That's the same as saying, we've said this before, we've noted this before, same as saying that this thing factors with a factor of x minus 2. The only way 2 can solve that equation is if that's true. Well, At this point, you can say, all right, well, how would this have to be then to make this all work out? Well, you're going to have a 3x, right? To multiply with that x to give you the 3x squared. Then to get a minus 10, the constant is going to have to be a 5, and it's a plus 5 added on. All right, so there's some like reverse engineering going on there to construct this. And of course, you can always make sure if you multiply this out, you should get right back to there. Well, once you have figured that out, then you would of course set this other factor equal to 0 and solve. And you're going to figure out that x is negative 5/3. Does that jibe with your graph here? Yeah, negative 5/3. That's between -1 and -2, and it's closer to -2, so everything seems to fit together and make sense. All right, for those of you then who are graphing enthusiasts, you can always try the graphical method, but of course you're always going to have to do a little bit of factoring in there also. Now, before we get to the third major method, we have to see a special case. On page 187, we examine the square, if I can spell it right, the square root method. Let's look at example 6. Part A, we have the equation 2x squared minus 16 equals 0. Well, it's a quadratic. There's my x squared term, there's a constant term, there's no x term. In other words, the coefficient of the x term is 0, so it disappears. But this still qualifies as a legal quadratic equation. Well, when you have this special case where the x term does not appear, then you can use this other method. First, as we do so many times with equations, isolate the x on one side of the equation. Let's divide each side by 2. So I arrive at this statement, x squared must be equal to 8. Well, why don't we take the square root of each side? Perfectly legal move, right? Because we know in our work with equations, whatever you do to one side, you have to do to the other. So I did. I took the square root of each side. Notice the plus or minus sign. X is going to have 2 different values. This has to be simplified. It's not acceptable to leave it in this form. If you notice, we're taking the square root of a perfect square. It's in there as a factor. In other words, I'm saying this. I've noticed that this perfect square 4 divides into 8. So I can think of 8 as 4 times 2. The square root of 2 numbers multiplied together is the same as the square root of the first number multiplying the square root of the second number. It's another one of our square root principles that we use. Notice you only need the plus or minus sign once. It's still presenting both possibilities. Now we can really clean this up. A better name for square root of 4 is 2. Again, you might say, hey, square root of 4, that could be plus 2 or minus 2. Right, but we've already covered the 2 possibilities there, so you don't need another plus or minus symbol. And there are the two roots of the quadratic equation. We used the square root method. Let's look at a slightly more complicated version of this same problem. Look at part B. X minus 6 quantity squared. When I say quantity squared, that means there's parentheses around there. Equals 18. Well, this one's already in this stage. Actually, this stage. Let's just take the square root of each side. What was inside the parentheses is x minus 6. So when I take the square root, that's all that's left on that side. On this side, I have my plus or minus sign, and then the square root of 18. Okay, that's good. We need to do some simplifying, and we need to isolate x. If I add 6 to each side, that isolates my x. While I'm at it, I can simplify the square root of 18. Do you see a perfect square that divides 18? Yes, it's 9. So I'll think of square root of 18 as square root of 9 times square root of 2. I'll rewrite square root of 9 as 3, and there's my answer. Okay, let me have you all work a couple out to make sure you're really getting the hang of this. Part 1, I'm going to assign you 2 problems here. Number 1, x squared minus 20 equals 0. Number 2, quantity 2x plus 1 squared equals 20. Notice that the 20 appears in both of these problems, so you'll see pretty similar steps to simplifying your answer. Okay, work those out, and then we'll come back and march on from there.